Everyone, just show of hands, who here was at the talk I gave like an hour ago? Awesome. Not everyone, so I apologize if you're here and you've never used TypeScript. I'm going to very briefly introduce TypeScript at the beginning to establish shared vocabulary, but we're not going to describe like what is the type system type stuff. If you now leave, I won't be offended at all. But for those who weren't there, hi, I'm Josh. As was very nicely mentioned, I work in open source around projects, most of which have the word TypeScript and or the word ESLint in their name. Talk to me outside of this context if you want about open source. I love complaining about the industry. It's great. And I wrote a book, which you should buy. TypeScript. Who here knows what TypeScript is and is ready to talk about it? Yay! The other room was more excited. That's fine. Brief recap. What is TypeScript? In order to answer that, what is JavaScript? JavaScript gives us this syntax, but again, to recap, JavaScript doesn't provide a standardized way to describe the intent behind our values. JavaScript just says the values and then the stuff you do to them. There's no way to say add a type annotation. That's what TypeScript gives you. Fun fact that I did not mention in the other room, there is a proposal to add this syntax called the type annotation or the types as comments syntax to JavaScript. It is very contentious and it will be years before it's accepted if it is, because it's a very tricky problem. So for now, TypeScript. You might see it on the command line. You might see it in your editor. Everyone sees red squigglies. And I want to talk a bit about those integrations because they're awesome. Now, I showed this, and I apologize for the overlap in the last talk, a bit of a live demo. Let's see. Nope. I'm just getting up VS Code. I'm not really a Mac person per se, so I don't really know what's happening right now. But I'm going to try to move my VS Code. There we go. I did it. OK. Greet.ts. Cool. So just to recap, and I did show this in the last talk. Again, apologies. Oh, sweet Jesus. This is going to be difficult. Turning into a Vim user now. There are all sorts of awesome editor services. For example, some stuff I actually didn't show in the last one. I just pressed Command and period on my keyboard. I'm going to just move to a new file. Greet.ts. You can just move everything to a new file. Oh my sweet lord, this is really painful. I might skip this. Oh, here's a fun one. Let's say you wanted to extract to a constant. Let's say every time this function gets called, you don't want to create a new console log. I'm going to extract to constant in module scope. What should I call this? Logger? Log? MyLog, thank you. MyLog. Look at that, look at that. Beautiful. Cool. So TypeScript gives some, enough of this awful experience. TypeScript gives some nice, I should have asked for a mirroring. I don't know why I didn't. Some nice things there. Now, one thing I mentioned a lot last talk and didn't go into much is that TypeScript is super configurable. TypeScript is not just for the projects that have always been using TypeScript. It's for all sorts of JavaScript projects. If you started off with a 9001 file project, you might not have the time to convert everything to the most beautifully strong TypeScript types, which means TypeScript can exist on a scale from weakly typed, which is not a negative term. It just means the types aren't as strongly defined, towards strongly typed, which means by definition, TypeScript is a gradually typed language that you can configure to be whichever emoji best suits your level of adherence to type principles. So to be clear, as we go into this, you don't have to type everything. TypeScript allows you to, skirt by a little bit, but TypeScript is more helpful the more strong your types are. So you can imagine those types are what inform a lot of the nice little dev tool thingies we saw. If you don't have as much typing, well, TypeScript can't help you as much. So let's look at the tsconfig file. Show of hands, who here has manually hand-edited a tsconfig file in their time as, oh yes, such a fun experience. TypeScript's configuration files are permissive by default. By default, they don't turn on all those strict settings, which means this block of code on the right, is Becca here? Becca's not. Again, what the hell, Becca, is not going to cause any type errors. But does anyone spot a potential problem with the code on the right? Something that TypeScript might yell at us for if we are more strongly typed? Yes?
You say the user constitute to prompts?
Yes.
And it's expecting a string?
Yes. Yes. That's not the answer I wanted. That's the final answer. You're too good at this. You're hurting me. I'm sorry. I'm just going to go on my own because I can't trust the audience to answer things in the exact order I wanted. Yeah, so there's an awesome compiler option that's off by default called no implicit any. Any is the YOLO let me do whatever I want type, not good. If you don't tell TypeScript what something is, for example, that function parameter user, it's implicitly any, which is fine by default. But if you turn on the compiler option, no implicit any, TypeScript will yell at you saying, hey, it's implicitly any. You didn't tell me explicitly what it's supposed to be, and I can't infer it from just its definition. Now, in theory, TypeScript could look at a thing and find all the places it's used, but that would be expensive, like slow, performance-wise, and it would be unreliable. TypeScript's purpose is to let you know where you mess up. If it takes you at your word, how can it accomplish that purpose? So we might give it a nice little string, and then, as was suggested, there's another issue. Prompt is a built-in browser API that returns null if the user cancels. So we might turn on the lovely strict null checks option, which tells TypeScript to tell us null is not allowed in places that aren't explicitly said as can be null. Beautiful. Now, both of these options are awesome. You should basically always use them if you have, at any point in time, the ability to turn them on. Please turn them on for all of our sakes. If you wanted to do strict null checking fixes, you might like make a conditional. They make your code better. They help you find bugs. And by default, they are turned on if you just enable strict true. That's all you got to do. Strict true just makes TypeScript much more useful. Now, TypeScript, as we saw here, can't catch edge cases if it doesn't understand your types well. So if you write code in ways that can't have their nuance expressed in the type system, you might have a hard time getting TypeScript to be helpful to you. And I'm going to show you now two of my least favorite syntaxes, the things that cause weird holes, unsoundness in the type system more than anything else. The first of these two things is the pair try catch. This is a fundamentally not type-safe concept. If you ever heard the phrase, it's like a go-to, it kind of is. Who here has written a try-catch in their coding journey? I'm keeping track of the 3 people who aren't raising hands. Let's say you have some code and you do enable strict true, which means you do have this lovely use unknown and catch variables option turned on by default. Sorry, I keep hitting the slides. TypeScript knows that the type of the caught error in a try-catch is unknown, or any, depending on whether you have this on. Unknown is like a safe any. You're not allowed to do anything unless you narrow. And that's good because, well, for starters, you want to be told if, let's say, you do something that assumes the error is a particular type, such as an uppercase E error. Because what happens if someone throws something that's not an error? That's totally allowed. That's valid JavaScript. The hell? Also, sorry, I have something in my teeth. That's so annoying. Okay. My God, slowly driving me unhappy. So JavaScript allows you to do that. There's nothing stopping you from doing that. There are lint rules we'll look at the idea of later that can stop you. But any code can throw basically any random crap it wants, which means even if you were to add the concept of like a throws keyword, a way to describe in the type system that certain errors might be thrown by a thing, other stuff might be thrown too. So try catch, well, the actual safe way to write this code would be to like narrow it. If error instance of error to check, is this actually what I thought it would be? So that's annoying. And I also want to emphasize the point, it's not just functions that can throw errors. Does anyone know what happens if you run this code? Which is, by the way, type-safe code. Does anyone know the name of the error that gets thrown if you have an out-of-range number passed to an array length? This is why TypeScript is good, why things are hard. This by the JavaScript specification, if you put an invalid array length, as in array's length, such as -1 or too large of an integer, it throws an error. So not only can function calls throw errors, object assignments, x equals y, x.y equals e, that type of stuff can throw an error. Horrifying. Any code can throw anything. You can never truly be safe when you're writing JavaScript. Let's look at the other thing of the two I mentioned. Arrays. Arrays are horrifying. What an awful construct to have to work in that we all have to. Pardon me. They're very useful. But this code cannot be made type safe easily in the TypeScript type system. Because what happens if, given this greet user function, someone throws over a 9001? Now we'll get an unhappy error saying could not, access to uppercase of undefined or some such. And this is type safe with strict true. The concept of making sure that the thing you get back from an array is within the bounds of the array is so annoying to enforce that although they did add a no unchecked indexed access to let you know that anything you get back from an array could be undefined, it's such a pain in the rear to enable that it's not enabled even with strict true. You have to opt in. But if you do a lot with arrays, it is actually kind of useful as a flag. It'll make sure that if you access an element in an array, you need to either assume it could be undefined or do something to indicate that the number is in the length of the array. Such as, well, there are two strategies I've seen. One on the left is actually checking, like in your code logic, which is kind of a safe way to do things. Or if you know that the number is fine, you could explicitly say, okay, index is 0 or 1, or whatever it is. For those who were there last time, that's a literal type union. But this is a pain in the butt. So I find that this is a great, like one of the best TypeScript features that I don't use. And in terms of TypeScript, I think it goes beyond strongly typed and turns it into kind of an overly aggressively typed kind of language, which is good. It's good that we have this option for people who want it, and it's good that the rest of us don't have to use it. Ooh, what a weird thing. So I want to go into a few architectural choices you might make before we jump into new syntax and keywords around the whole try catch isn't type safe. Because I see a lot of this in code. I see a lot of if invalid case, or if unhappy path, as we sometimes call it, throw new error. Throw new error is a very common thing, but throw new error is not type safe. There's no way, as we saw, to make TypeScript understand that only specific errors could be thrown by a function. It's practically impossible. So just describing in shorthand what one might call that function, you might have an @throws in your JS doc, that's a comment. If someone were to call your function, nothing in the type system would let them know this is unsafe. So one option would be to, instead of throwing, return undefined. It's actually less code in this very specific canned example. If the user doesn't exist, return undefined, which you can represent in JavaScript shorthand as db.getBy optional chain preferences. So if the user wasn't found, just return whatever, null, undefined. This is my favorite of the options I'm going to show for this. And then if TypeScript sees you doing that, it would let you know you forgot to check does preferences exist. So you could do something like if preferences or whatever logical check you need. That's not even a TypeScript new feature. We already have seen unions. This is just a good way to use existing features. And another good way is, if you want to throw an error, if you want the error to be informative, don't throw it, just return it. This is more like what someone was asking Go and Rust are like. Just return the error. The only difference between this and the original is return instead of throw. And type narrowing will still be in play here, where you have to check, is it, let's say, instance of an error instead. TypeScript. And lastly, discriminated unions, which we did see in the last presentation. What a great name, horrible name. Let's say that you were to write the function with this set of types, where you can either have a success result, succeeded true, with the preferences, or a failure result with succeeded false and an error. Then, in your code, you return a complex object. This is a lot more code than the other options. But it then means you can do stuff like if result.succeeded. And TypeScript would let you know if you forget to. Now, I don't use discriminated unions often, but when I have multi-state, like 3 or 4 different cases, they are kind of nice. Cool. I think that's the most boring set of slides I've got today, but I think they're useful for architecture stuff. Now I'm going to actually go into TypeScript features, new things that most of us are not yet using. Is everyone excited for that? Yay! Cool. When I see people start to sleep, then I ask. Who here's heard of satisfies? No, almost no one. Who here has used satisfies? Almost no one. 1.25 hands. Awesome. This is actually kind of difficult to make type safe. This set of 1, 2, 3, 4, 5, 6 lines. 5 lines. Let's say you had a palette variable, and you wanted each of its values to be either the tuple or tuple of 3 numbers, or a string. And let's say you wanted to have red, green, and blue as the key names. Does anyone see the typo? Or the misspelling? Blue. I was in Europe when I wrote these slides. Yeah, it's blue. So how do you both enforce the names of the keys and the types? Well, you could write a record type. That's a built-in generic type. Takes in 2 type parameters or arguments, the keys and the value types. So this would be red or green or blue. And then the values are RGB or string. And that would give you the complaints on blue. So that's nice, good for us. But then it gives you a complaint on 2 uppercase also. Why would it do this to us? Well, we told it to. We told it that this object, it has 3 keys, red, green, blue, and each of the values under those keys are either the tuple or the string. We told it palette.green could be either of these things, even though it can pretty easily read our code and know that green is a string. We lied to TypeScript in a sense, or we asked TypeScript to be obtuse and annoying to us. Wouldn't it be nice if there was a way to tell TypeScript that a particular value satisfies some shape without widening the type of that value? Like some sort of satisfies keyword. That's what that does. Satisfies says, make sure my thing satisfies this shape, but don't mess with it. I know what the type is. Keep palette.green as a string, not the union. Satisfies. So in summary, satisfies, ooh, I'm tripping. Use satisfies to ensure that a value fits a type without widening the value's type. I'm told there are small edge cases where it might change the type, and they're out of scope for this presentation. Cool. Second new feature that I like, NoInfer. It's not a keyword, it is a built-in type. Let's look at something that's also kind of hard to make type safe. GetIndexOf. It's a generic function. It just wraps index of on a string array. Let's say you take in values and a value. Does anyone see the typo, the misspelling? Which word is it? Blue. It's actually pronounced. So if we wanted to catch this typo, it's actually really difficult without this new NoInfer thing I'm going to show you next. Because I'm just going to go through how TypeScript's type inference algorithm works, NBD. It looks at all the possible things that could be the T, and then sets T's type to be a union of those possibilities. So for this, it would first look at blue, spelled correctly. It'd say, OK, T is blue. Then it would see feta, so it would say T is the union blue or feta. Then it would see another blue, and then that's the type argument. Cool. Same algorithm if we have the typo. First it sees blue, then it sees feta, and then it sees the other blue. So that's the type argument. Well, that's annoying, because I would sure like a type error telling me I misspelled that last blue. What I'd really like is a type operator that could tell me that this particular type, in this case value T, should not be used in the inference of the generic type argument. I want some kind of NoInfer, which is what TypeScript's adding. Yay. NoInfer says, shut up about this. Don't use blue when you're inferring the type of T. So blue doesn't get used in the type argument, which means the type argument doesn't include the typo, which means we now get a complaint saying your value argument is a type that is not assignable to your T. Yes. Cool. I see people writing, so I'll wait a bit. Oh, I have water. So to recap, use NoInfer to make sure that a parameter's type does not get changed. Use NoInfer to make sure that a generic parameter, type parameter, does not get changed by an argument that shouldn't touch it. Okay, cool stuff. I'm going to go into some more wild and wacky things that the community has done. Because in addition to a type checker and a syntax and everything, TypeScript provides a lot of really nice APIs. A lot of little nice programmatic functions and things you can call in Node. And they can be pretty useful. To start, the thing that I'm actively working on day to day. Who here lints their TypeScript code? Who here, awesome, who here uses type-checked linting? No one. I'm glad I'm here. You should probably lint, so I'm glad a lot of people raise their hands. I know not everyone has the time or the team interest, but it's nice to do. If you're at the scale where types are worth it, there's a very good chance, not 100, but a very high chance, that linting is worth it too. And when I say linting, I want to first establish that linting is not type checking. A lot of people call TypeScript a linter or say TypeScript is linting my code. And much like the difference between arguments and parameters, technically that's wrong. And no one ever remembers it, and that's a whole thing. But there are 3 common forms of static analysis that are popular in the web today, ranging from speed, the formatters like Prettier, dprint, which are real fast and real dumb in a good way. They don't make any logic, they just reformat. And then there's the power, TypeScript. Very powerful, it reads your entire project, builds a full understanding, but it's slow as a result. Who here has had to debug TypeScript compiler performance issues? Yeah. Sorry to hear that. In the middle is a linter, like ESLint, or Biome now too. Linters run on one file at a time, which means they're faster than TypeScript, type checkers. But they're kind of dumb. They only understand one file at a time. So if your file imports from another file, the linter typically won't understand what's in that other file. So just a couple quick examples. Linters are actually awesome even if they're dumb, even if they don't have TypeScript's power. There's a built-in ESLint rule called logical assignment operators. They can look at that code and let you know, you silly goose, I can auto-fix this for you to the nice new syntax. Who here knew about this little guy, this little friend here, this little or equals? Isn't that awesome? Okay. Am I the only person who really deeply cares about saving 3 characters? Another one would be in TypeScript ESLint, the ESLint plugin for TypeScript. We have rules that'll let you know if there's some savings, some stylistic niceness to be had. If you use a type assertion, quote Dylan as Dylan, there's actually like a shorthand for that. Dylan as const. Look at you. Nice. But syntaxes and types, those were pretty unimpressive, I think. From a technical perspective, we didn't use TypeScript's types. But there is a new classification of lint rules now, of linters, that is able to take in TypeScript's APIs and use them to inform more powerful lint rules. It's like a 4th class of linters, which is what I work on, and you're going to hear about it now. Here's an example of one of my favorite lint rules, TypeScript ESLint await thenable. Who here knows what a thenable is in JavaScript? Almost no one ever knows this. A few. A thenable is the concept of something with a dot then. If you await something with a dot then, you'll asynchronously get back the result from the then. That's an oversimplification. The most common thenable in JavaScript is the built-in promise class. Who here has used a promise in JavaScript? Quite a few. Does anyone know what happens if you await something that's not a promise or thenable, such as undefined? What? That's right, nothing happens. Technically, it takes up a little microtick of time, but nothing happens. So this await is basically unnecessary, which the lint rule could let you know. But the only way the lint rule knows that that's an unnecessary await is to know what the type of console.log is. How would it know otherwise? Maybe you have your own fancy schmancy console instead of the built-in one where everything's asynchronous. You maniac. So this is a contrived example. It can remove the await for you, but I've never actually seen someone write await console.log. Let's look at a bigger example. Who here writes React or Preact or similar? Almost no one. And yet you now am being asked to look at this code and make informed. One of the advantages of linting and TypeScript is that they can read your code quickly and let you know if you have bad things in code, the nature of which you don't have the time to understand. Does anyone see the await in the code? Yeah, it's there. The lit rule will let you know, aha, on click is actually type returns void. It's a function that returns void. So how would we fix this? Well, one option would be to change the thing to be promised void, so we have this await in there. But as indicated by the skull emoji, I say to heck with that. What if, just hypothetically, this button is only ever rendered with synchronous on clicks, which means we could remove the await. Well then, if we can remove the await, that makes it synchronous code. And fun fact about React, set states are synchronous functions, but they queue state changes asynchronously. So doing that, running true, something running false, is unnecessary. So that code's unused, which means the entire onClick and disable function is unnecessary because all it ever does is call onClick, which means that our running state is unnecessary because it's only ever going to be false, which means disabled false is only ever going to be the case for the button, which means we can remove the button disabled in the first place. And we just removed a third of our code with linting! Woo! Yeah. Nice. Cool. There are also a few other fun lint rules that could have been shown there. There's a lint rule that detects if a function is async but doesn't have any awaits. Doesn't need types for that, just syntax. And my favorite lint rule is the most contentious one in the ecosystem. No floating promises. If you create a promise, handle it somehow. People hate that rule, but it's caused a lot of bug fixes to get, written. So type check linting is awesome. At the end of the presentation, I'll again have links, references if you want to see more. I'm not going to show you your ESLint configuration here because I want you to like me. But a little bit more on linting. One of our big work points in TypeScript ESLint the last couple of years has been to make typed linting really good. We see there being a power scale from traditional zero syntax to what's the cutting edge in open source today, type identity. We take a look at, let's say you're on click and we know the identity of that type, function that returns void. But there's actually a next step coming next. This is, by the way, the first time I'm speaking about this in public. This is very exciting stuff. This is, I don't have an equivalent exciting historical event, but it's, the closest that comes to mind is Watergate. This is really big. Anyone here heard that the time Nixon worked in a restaurant? Okay. Soon we're going to have type assignability checks. I know, calm down. Calm the hell down. Jesus. What is that? So let's take a look at this code. Interface mood is structurally the same as interface vibe. And we have written state of being equals mood or vibe. It would be sure nice if our lint rule could let us know, you silly goose, vibe is structurally the same as mood. Wouldn't that be nice? Unlike all my previous examples, I'm not about to tell you how to do that. It's not available yet. But there is a newly made publicly available TypeScript API that we are going to start using very soon, any month now, in TypeScript ESLint. I'm very excited about this. It's called checker.isTypeAssignable2. There's a huge issue and set of resources you can read about it on GitHub. The TLDR is, we're going to do nothing with the info that the TypeScript team told us we can use it. Once our next major is released, we'll say that we can use it. Oops. And then we'll let the TypeScript team know if things break. We're very scared about using this API. TypeScript has a lot of caching internally, and we don't know what we're going to break. We're pretty sure we're going to break something, and we're going to keep our fingers crossed. So I'm really excited about that. That's going to be a whole thing. Anyway. A couple more assorted pieces of tooling. Who here has used Knip or knows what it means in Dutch? Anyone want to guess what it means? It means cut. Thanks. Yeah, nice. Let's look at this code. Does anyone see the unused variable? I have 14 minutes of this, so. Banana, yes. But interestingly, thank you. Interestingly, a linter would not be able to detect that banana is unused because it is kind of used in the file. It's exported. You need project-level linting. You need a tool that could run in your code base and let you know, aha, there's an unused export. No one is using this. That's what Knip does. Honestly, I had a hard time writing these slides. It's so straightforward. I couldn't figure out like what to put on it. But Knip doesn't just look at values, as you may see here. It also looks at your package JSON and lets you know that not only may you have code that's unused, you might also have dependencies that are unused. Awesome, yeah, because I have every single project I have run Knip on greater than a couple dozen files has had not just unused code, but at least one random dependency in the package JSON with some common name that no one is really confident enough to remove because it might break something in production. Knip. Knip it before you ship it. That's the project's cute tagline. Love Knip. All right. So use Knip to find unused code and dependencies. Last thing I want to show you, type checked. This is from the TypeScript team. That's why they haven't been working on TypeScript as much as I wanted them. No, this is really cool stuff. I managed to go almost the entire conference without talking about AI, and I really, really resent that this was a natural fit to this talk, because I really hate overhype. And as cool as AI is, my God, it's overhyped. Let's say you had a prompt. Anyone here ever live in Seattle or been to Seattle more than a couple days? Y'all, the rest of you are missing out. Seattle is a lovely city. Truly, this is not a setup for a joke. I really like the city of Seattle. Give me an array of objects with description menu strings for things to do on a rainy day. I asked ChatGPT this. This is from the TypeChat blog. You might get back that. That's like a pretty standard use of like ChatGPT, typical what we currently call AI. Maybe you want a little more information. Maybe you want a kind that's one of three things. In code, this might be a type union. And maybe you want to add in whether it's vegan friendly. Fun fact about Seattle, very progressive. Everything is vegan friendly in Seattle, basically everything. Even the fish market is vegan friendly. That's wrong. ChatGPT 3.5 gave me this crap, and I couldn't get it to be correct. Seattle is very vegan friendly. Which brings up a very important topic, a very important point for this presentation. Today's AIs are stupid. That's not clickbait. That is a technically correct thing to say. It is clickbait. They are stupid in that they are not smart. They are not intelligent. AI is the wrong phrase for them. They are an incredibly, incredibly well-informed autocomplete. They're a globally aware autocomplete. A globally aware autocomplete. It is the smartest stupid humanity has ever created. And I want to be very clear on this. AI is incredible. It's going to revolutionize so many things. It's already revolutionizing so many things. Like truly, the potential. We're within the first few years of mainstream adoption of this crap, and it's already doing all sorts of cool stuff. But my God, is it bad at reliability. It's autocomplete. It's not AI. So if you were to try to, let's say, define the schema for what you wanted back, it would not be a sound or smart business decision to rely on the AI to give you back this schema on its own. It's autocomplete. It doesn't understand types. It doesn't understand your intent. It's just giving you what it thinks you might want. But wouldn't it be nice if you had a tool that could try to describe this in whatever it has found to be the best way to tell the AI. And then if the AI gives you back something that's not in the shape, it then tells the AI for you, hey, you messed up this shape. Maybe it could run the TypeScript type checker on the code given back from the AI to make sure it satisfies the shape. Well, if you were to, let's say, read your schema from a TypeScript or .ts file, and then use the TypeChat APIs to create a validator, which is the thing that does the thing I just said, and then you were to create a language model and a translator from that model to your validator, so from model to validator, and then ask ChatGPT or whatever you're using through that interactive type chat function, then it would be able to strongly type your AI responses. It would be able to give you IntelliSense saying, these places are type from the last slide place, or whatever it is. So that's cool. I strongly believe that AI is amazing. I also strongly believe, has anyone here heard of the Gartner hype cycle? We are in the peak of the Gartner hype cycle. Does anyone remember what happens next in the Gartner hype cycle? Peak of inflated expectations, trough of disillusionment, plateau of enlightenment. I'm very excited about the plateau of enlightenment. Cool, so let's recap. This is the slide set where it makes sense to take a photo and not just write things down. TypeScript adds type syntax, type checker, editor helpers, super configurable. You don't have to be super strongly typed. Some levels of type strength are too much for me. Type systems cannot comprehend try-catch. They can't comprehend throw. It is literally impossible to. It's not their fault. Satisfies lets you make declarations that are not unnecessarily wide, but still get checked. And NoInfer helps keep certain arguments away from the inference for your type parameters. Type check lint rules are fantastic. Highly recommend trying out the typescript-eslint docs. Linting is one thing to use. There are other nice things as well. Look forward to type relationships. Knip is awesome for finding unused stuff. AIs are stupid, technically speaking, and use type chat if you want to get type-safe output types from your APIs. Last little slide here for resources, the websites of all the things I showed. Cool. And that's all I have for you today. Thanks for coming, folks.
Going back to the satisfies feature,
Oh boy.
how is that different from as?
Ooh, great question. How is that different from as? We saw satisfies, we saw as in the last talk, I guess. As will widen the type. Satisfies will not widen the type. So in the example before, as would make it string or tuple rather than just string. Does that answer what you're looking for?
Yeah, I wanted to know if I could lie. I wanted to know if I could lie with satisfies.
Ooh. I believe, with everything in TypeScript, truth is not a binary 0 or 1. As far as I know, it is difficult to impossible to lie with satisfies, but I don't know it deeply enough to definitively say you can't lie with it. I would be very surprised if you could lie with satisfies. It's as confident as I feel confident getting. You look, and pardon the pun, unsatisfied with that response.
No, that's what I was asking. So yeah.
Cool. Pardon me. Hi.
Thanks. Dramatic pause. I don't know
Yeah.
if it's going to be worth it. In really large TypeScript projects, assuming we've done things like enabling a lot of strict modes and getting rid of a lot of implicit typing, how can we speed up like TSC for very, very large projects? Any thoughts there? Anything you can recommend?
Yeah, great question. How to speed up TSC, TypeScript. The fact that you asked it that way makes me think you are currently facing this problem at work, and I'm sorry to hear that as well. There are a few strategies. For one, TypeScript has the concept of project references, which allows you to have TS configs, little granular parts of your project that refer to each other. Kind of like how in a monorepo you might have different packages. The nice thing about project references is that they cache at the project boundary. So if A depends on B and B is massive, and you change A, you don't need to recheck B. So that's the big one. For bigger projects, that's the big recommendation. Other than that, there are tools you can use to profile type checking, like Specialize provided by TypeScript tools. Most of them end up in the way, when I've used them, they end up finding that you will typically have like 2 or 3 ginormous, accidentally huge types somewhere, and once you fix those types, your project speed gets much better. The rest of the cases are that most of the time it's that projects use a lot of libraries, and those libraries have fancy, complex types. Like I've seen multiple versions of Lodash with subtly different generics being used, and at that point, your choice is to either stay slow or stop using the advanced features, neither of which is a particularly great choice. Good luck.
Can you say the second answer again? What was the second?
Shoot, what was?
You're saying that fancy types, like generics, are just longer to
Yeah. So if you have large, complex generic code, that will be slower to type check. So if you do too much of that, it will be slow. But
There's no fix for that.
stop doing that. That's why project references are nice, because you can have ridiculous fancy generic types inside a project and not let them leak. That's like typically the strategy. It's pretty good, by the way. TypeScript can be pretty fast. It's just when you have a lot of them that it gets slower over time. Typically more, except for a couple, 3 large ones, in my experience, it's typically a lot of paper cuts, not like huge chunks repeated. Everyone's like, can we leave? No.
Yeah, I have a question for projects that doesn't use TypeScript. In your experience, what have you seen where people improperly converted like Flow to TypeScript? Any issues with those?
Yeah. Fun fact, I led the Codecademy conversion to TypeScript, and every single bug we caused was out of arrogance. It was the ideology when you're converting to TypeScript, in my opinion, should almost always be, don't change the runtime behavior. Don't fix a bug as you're converting to TypeScript, because your giant conversion pull requests are huge. It's hard to check everything. And I caused multiple bugs sheerly out of arrogance of ignoring my own advice there. But yeah, most of the time, most of the way towards TypeScript is fine and easy, and then you just have random little bits of code that are not type safe, that are hard to represent in TypeScript. Use an any until you have time to refactor, and you're probably fine.
Can I quote you on that?
No. This isn't being recorded, is it? No, actually, use an any. People on the internet are far too absolute in their programming recommendations, right? Like, there are very few things that are absolute that should always be respected, like buying my book. Like, using an any is sometimes fine in the right scenario to save yourself 3 hours of investigation.
Right. I have seen an instance where someone would create a type, but make it any, so later on in the project, they can, give it the type that it needs to be. So, thank you.
Sure, that's a great strategy. Google actually had a really good talk at a past TypeScript conference about their strategies, such as that one. Yeah.
Is it, sorry. You were talking about unknown.
Unknown.
As being
It's for the recording.
Oh, sorry.
Can you have a mic, please?
Sorry, my ADHD.
Mine too.
Yeah. So in the recommendation to allow the use of any or use any to sort of move past something, is there any reason to not use an unknown in that case?
Great question. I should have been more verbose and clear in this. There is a set of strategies one would typically take when TypeScript is giving them pain. Like if there's something that's hard to represent in types, the strategies, this is not comprehensive, this might be out of order, but read the error message type stuff, really try to figure out. Refactoring code if you're not doing a giant version PR. Use unknown because it's the safer any. So yeah, I would use unknown first, but then sometimes you're accessing properties on it, it's a pain, use any. The very last ditch you should try is a feature I wrote in TypeScript called TS-expect-error. Who here's written a TS-expect-error? Yeah. It shuts TypeScript up for a line. It says, expect a type error to occur on the next line or this line, don't report for it, which is horrifying. You should not use this thing. It's a last-ditch resort.
Yeah. Okay. Cool.
Yeah.
Thank you.
Well, this has been an absolute pleasure. Thanks, everyone, for hanging out.